All right. Welcome back. So we are in week 2. Um, we're going to start getting into the actual math. Some of this stuff will be familiar from years past and a little bit of math you did here and there. It's really sad, but most classes, most years of math don't teach you much statistics anymore. It's in the curriculum for almost every single year of middle school, and like algebra 1 has some statistics in it. Geometry is supposed to have some statistics, but we never get to it. Most teachers are like put it at the end and then they never get to it. So a lot of people get through middle school and high school without really seeing stats. So a lot of people, this is their first real foray into the stats stuff. So I'm thankful to be your tour guide. So today we're going to talk about measures of center. We're going to talk about the mean, median, and mode. There's a lot of fun little catchy YouTube videos that have some fun songs and things if you can't remember them. But hopefully I'm able to make it easy to remember which is which. So that's what we're doing today. Today's actually not a super long class. There's something on my screen. Just a second here. Okay, it's not a super long class, and we have no lab this week. There will be 2 labs next week, I believe. Yes, there's 2 labs next week, but one of them just uses the continuous data you already have, so it shouldn't take very long. Neither one of them is going to take forever, take a super long time. But there will be 2 labs next week. I'll be walking through one of them on Tuesday and the other on Thursday next week. But that's next week. We don't care about that. That's future our problem. So today we're going to talk about mean, median, and mode. And yeah, so let's just get going.
Can I really quickly ask a question? Because I know the lab's due tonight and I've been trying not to turn it in before I fully understand if I did everything correctly, but I can't even seem to get a histogram out of the continuous set to come out the way I want it. And I asked my co-requisite teacher and she told me a whole different way than you did. And so I'm like, okay, I don't know why it's not like it doesn't show the axis on the vertical or the horizontal, and then they're not connected. And um she wanted me to do the lower limit and upper limit. I had told her that you had said not to, and she said pretty much without it, it's kind of hard to do the histogram. I don't know what I'm missing.
Okay, it sounds like you are putting in a bar graph rather than a histogram. That's what it sounds like. Because
Okay.
the bar graph is going to give you spaces between your bars. If you're getting spaces between them, you've inserted a bar graph rather than a histogram.
Okay. No.
And to put the axis titles on, you need to add chart element. So you click on, so you're going to, once you're in the screen for your that so you click on your graph and you know where your options are to make it pretty and all of that.
Yeah.
Top left, there's add chart element. That's where you add your axis titles.
Okay. So for the continuous, if I had um like phone calls and then seconds, the phone calls would be on the left.
So the it's going to be frequency is going to be on the vertical, and then your horizontal would be like minutes of the phone, be minutes or whatever, be phone call length or whatever your,
Okay.
yeah.
Okay.
So it sounds like you're trying to insert a bar graph instead of a histogram. So look at the pictures when you're doing insert and make sure that it shows the bars basically touching each other in the picture.
Okay. Just as you were just walking me through that, I just created one.
Uh-huh.
Um yeah, I don't know. I guess it was also the bin width, the interval width.
Uh-huh.
Because I have such a giant jump from like 20 to 720,
Uh-huh.
I was doing them in 99 interval lengths.
Uh-huh.
And that gives me 1, 2, 3, 6, eight bins. And um,
That's great. I love
okay. Okay.
That's perfect.
I don't know why I'm so overwhelmed with that. It seems so simple. And
Okay.
I think everything I'm just making it harder than it needs to be,
That's all
honestly.
right. That's the story of my life. I do that all the time. I overthink everything. So yeah, that sounds perfect. It sounds, yeah, now that you have a histogram and it seems like it bended up perfectly for you. So just add your axis titles now.
Okay. I appreciate that. Thank you.
No problem. No problem at all. Yeah, I probably at the end of class I might be able to walk you through it again, but there's a video. Um there's a video, the instructional video right under the lab in the content that also walks you through it. So the video of last class plus the video right underneath the lab itself. So I can show you. Hold on. Uh, 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 uh. So if you go down to our week one materials, down here below the lab one, there's instructions for lab one. There's a video here as well. There's video instructions for the lab as well. And then also at the end of last, if you want the Zoom meetings, I don't know if y'all found where those are, but the Zoom recordings, if you click on Zoom lecture recordings, I put them all right here. Except for it says lab two instead of lab one. I'll fix that. I didn't mean to say it was lab two. But so
Okay.
at the end of this, you could look at that also. Every time I record these Zoom videos, I will post them in the Zoom lecture recordings because they're much better than my pre-recorded videos. The Zoom ones are. I'm a better teacher now than I was back then.
Thank you.
You're welcome. All right. So let's go over. I wish this would go away. I mean, it probably will eventually. I don't know why it lives there. Okay, whatever. We're just going to ignore it. Let's move on. All right. So we're going to talk about measures of center today. So we hear average all the time, but people use average to mean mean or median. Some people will flip-flop back and forth. Most of the time, average means mean, but it's not across the board. When we say average here, we're going to mean mean. Sorry. Okay. So we hear it all the time, average miles per gallon, national average commute time to work, average household income. Um, we hear, what the heck? Okay. The average American woman. Is it really the average American woman really 5'4"? That just seems short. I mean, I'm 5'2", so I'm below average no matter what. That seems really short. It's possible. Okay. Why won't this go away? Is that on? I don't know how to make it go away. There we go. I'll just move it down there. I'll just drag it down. That'll work. All right. So, first we're going to start with mean. So, even though it is the arithmetic mean, we're going to just call it the mean. So, this is the normal average where you add all of the values together, then you divide by how many observations you have. When we're dealing with population mean, we use this little symbol right here. It's called mu. And let me tell you, when I draw a mu, it's really ugly, but it's basically like a U with a tail. Mine always just looks like this. It's really ugly. Yeah, it's really ugly. But anyway, that's a mu. That's when we're dealing with the population mean. So in this class, or the population mean and the sample mean are calculated exactly the same. They just have different symbols. The sample mean has this symbol right here. We just call it X bar. So when we're dealing with a sample, it's X bar. When you're dealing with a population, it is mu. And the population mean is a parameter, the sample mean is a statistic. So mu is a parameter and X bar is a statistic. So whenever we're dealing with populations, we use fancy Greek symbols. When we're dealing with samples, we use boring symbols. So our X bar is the boring symbol. It goes with the sample. Mu is the fancy symbol. It goes with the parameter or with the population. All right. So this is just the formula, but you just add all of the observations up, divide by how many there are. If you get a decimal for your answer, we generally round to one decimal farther than our raw data. So if our raw data was all whole numbers, you'd round to one decimal place. If our data had one decimal place, you'd round to two decimal places. So we usually round to one further. My open math will tell you where to round, so you don't have to worry about that so much, but that's just kind of our rule of thumb. So when you're dealing with uh like hand-in homework or like your own project later on, that's kind of our rule of thumb. If I don't tell you where to round, I'm not going to hold you to it. Just round to where, use your heart. Let your heart tell you what to round to. I do that all the time. I frequently have students say, Miss Kleiss, why did you round to three decimal places? I'm like, I don't know. It's just where I chose to round. This happens. All right. So let's compute the mean here. So this data represents the travel time in minutes to work for 7 employees of a startup development company. So we're going to compute the mean of this data. So I'm just going to add them all together. Then I'm going to divide it all by, there's 7 of them, so I'm going to divide it by 7. So this is the math I'm going to do. About 24.9 approximately. So this is all the employees. So this is a population. 7 doesn't seem like it could be a population, but this is the entire office. The entire company has 7 employees. So my mean, my mu, population mean is 24.9. So we're going to randomly choose 3 of these employees. We're going to just randomly choose 3 of them. So I've got 36 plus 23 plus 5. This is my random sample. We're going to pretend I randomly chose them. So my X bar is 21.3 because that is my sample. I'm not going to do it again, but all of my random samples, all of my sample means are going to be different because it's a sample. It's not the whole population. In order to be super accurate, you need to sample the entire population. But it's not always feasible to do that. We can't always sample a whole population. If I have like RCC students, I mean, we have thousands of RCC students, it'd be really hard to sample everyone. So that's why we do samples. Or it'd be hard to poll everyone. That's why we do samples. So sample mean calculated the same way, just use X bar. Population mean, we use mu. On your hand-in homework, it's going to ask you to calculate the population mean and the sample mean. So the sample mean, you are not taking a sample. What I give you is the sample. So don't take a sample of what's there. Use all the numbers there. It's just a sample. Your answer is going to be X bar rather than mu, if that makes sense. All right, let's move on.
So on the homework for the hand-in homework, you don't want us to pull out sample numbers out of the sample. The sample's already there.
Right,
That's what you're
exactly.
talking about. Okay, good. I was like, oh no, I just okay.
No, the sample's already there. What I gave you is a sample. What I want from you is I want you to just basically, I'm making sure that you see that you know that you calculated exactly the same way.
Okay, I did it all. I just was making sure because I was like, if I have to just pull out numbers, I did it all wrong.
Nope,
Awesome. Thank you.
you did it right. Good job. Usually I have like 1 or 2 students every term that pulls a sample out. And so that's why I figured I would say it because there's usually just 1 or 2 of them that do it every term. So I wanted to make sure to make that clear. And I think probably I need to reword the homework, but it just hasn't happened yet. All right. So I would like you to calculate the population mean of this right here. So this is a class of intro statistics. There are 10 students. Go ahead and calculate the mean. I love when the answer is a nice whole number. Okay, so this is a sample. All right, this is a population, so we're going to use mu. I told you my mu is ugly. So I got 79. How'd y'all do? Y'all get 79? All right, so I'd like each of you to get a random sample. Actually, if you have a fancy schmancy calculator, I can tell you how to get a random sample. I'm going to show you on mine. It's kind of cool. Where is I need to get to, okay, let's see here. I'm going to get my calculator open real quick. Give me a second. This is useful. This calculator can do so much. It's very cool. All right. So if you wanted to take a random sample, so generally I would say, let's say these are numbers 1 through 10. So Michelle up here would be number 1 and Juan down here would be number 10. So to get a random sample, so what I want is for my calculator to choose 4 of these test grades and not repeat them. I don't want them to give me any of them twice. So if you go to math, the math button is right here underneath alpha. So hit math, go over to number. Number is the second one, actually. Is it under probability? I think it's under, yep, sorry. Math and then prob, and then rand int no repeat. So it's number 8 right here on mine. So lower, I want 1. I want it to go from 1 to 10. And I want it to choose 4 of them. So it's going to give me 4 numbers here. So it's telling me to use number 8, number 9, number 5, and number 1. And those are going to be the 4 that I'm going to choose randomly. So 8, 9, 4, and 1. These are the ones I'm going to use in my sample. If you don't have your calculator or you don't want to use the calculator for that, I would like you to choose 4 of them and calculate a random sample, a mean of a random sample. And then just, if you get your answer, just type it into the chat. And it's okay if you don't want to do it. I'm not forcing anybody to participate, but I would love to see the difference that we get from our samples. I got 82.75. That was my X bar. So I'm going to do 82.8 because I'm rounding to 1 decimal. So we have an 86. I have a 76, 80.75, 79.5. That one's really close to our population. 76.75, 78.2. It's good stuff. Look at how different all of these are. In mine, oh, there's an 80. See, 80 is really close to the population also. Look how far some of these are from the population, though, because our population's 79. Look at 86 is very far from the population. That's crazy. It's kind of just shows you that it's if you can use population, it's a good idea to do so. Thank you all for that. Good job. Questions so far? Are we doing okay? All right.
If you were to see some of these statistics like in a book or something, can you take the sample size average and project that to population? Or if you saw the mu, does that tell you that they did average the whole population?
Yeah. If you see a mu, it is a population. It means that they did the whole population. And I love that you mentioned taking all of these averages and averaging them together. Later on in the term, we are going to be taking a bunch of different samples and you find the mean of each sample. And then you, like, for example, I would take all of these right here. I would take all of these and find the average of all of those to try to get me closer to what the population average is. This is trying to remember, chapter 7, I think we're going to get there. So perfect. I love that you're looking ahead and trying to think about that. That's amazing. Good job. So yeah, if I found the average of all of these, it probably would put me pretty close to what the population mean is. So that was great. Good job. Okay. So now let's talk about median. One of the ways that I remember what median is I think of like the median in a road, because the median is in the center of the road. So median is just the center of our data set. So you take your data set and you're going to arrange it from smallest to largest. And then the median is just the center number. We frequently use median if we have like some large outliers. Like if I had an extreme value, I might use median because an extreme value is going to skew my mean. It's going to pull the mean down or up depending on if it's extremely high or extremely low. So the median is sometimes the better measure of our center. So let's go back to our travel data. So I'm going to take this data and I'm going to arrange it from smallest to largest. And I'm really bad at doing this. I almost always miss something. So I have to cross them out as I go because I'm just really bad at arranging things. And it's really nice and easy when it's an odd number because the center data value is really easy. There is like one right in the center. This one right here is in the center. At 23 is the smack dab, our middle data value. So our median, and there's no fun symbol for median. I don't like that, but there's no fun symbol for it. Sometimes we just do MED. So our median is 23. That is our center data value. And we had what, 24.9 was our mean. So it's slightly lower than our mean. But this one right here is kind of extreme low, and this one's kind of extreme high. So they both kind of affect our mean.
So if there's two centers, do you add them and then divide by 2?
Yep, that's where I'm. Yeah, look at you on top of things. I think that's my next slide. It's exactly what we do. So we hired another person. This new employee has a travel time of 70 minutes. So now we have an odd number or an even number of data values. So once again, let's arrange them from smallest to largest. Okay. So now our center is right in between these two. Those are our center two. So we do 23 plus 26 and divide by 2. I know I could do that in my head, but I don't trust myself. So my median would be 24.5. So the median doesn't have to actually be a value that is in our data set. It just has to be the smack dab center of our data. So 24.5 is right between those two values. So that would be our median here. Questions? but we don't do population and sample of median. Median is, it's always population. And it's just smack dab in the middle. We frequently see things like median home prices. Things like that, median makes more sense because um, if you have like foreclosures where houses are selling super cheap, it would drag the mean down. Or if you have multi-million dollar houses, like maybe you have one or two multi-million dollar houses in with a bunch of other ones, it's going to drag that mean up and it's going to make people think that the values are higher. So using median is a better measure when you have extreme values.
You always have to have, so because that one gave you a decimal, that's fine. Like
That's
on the homework for the like number three, where it gives you all the dollar amounts for the phone bill.
yeah.
Is that, do you want us to keep it consistent with after the decimal? Like, so like two numbers like there is in the rest of them? Like, does that make sense? So
Yeah,
say the,
because it's money, all of just basically just consider it money and just round it to decimal places. That's kind of one of the exceptions of rounding to one extra decimal place. I mean, it's money, so we write money as
yeah,
money. So
okay.
yeah. I think if there's a specific reason why we need to round where we round, then do it that way. Because you're talking about the phone bills, right?
Yeah,
Yeah. So just go ahead and stick to two decimal places because it's dollar amounts.
okay, thank you.
Yeah, no problem. All right. Let's go ahead and let's find the median of these song lengths. So these are 10, is it 10 songs? How many songs do I have here? Let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's 9. So let's order these and then find the median. I will order them for you, even though I'm really bad at it and I don't trust me. I will order them and then you can find the median. Make sure somebody calls me out if I do it wrong. See, I almost put 208 down before 206. Go ahead and find the median. I think I even made this really easy for you because I put 5 on the top and 4 on the bottom. So because this is odd, if you got 270, 217 is the median, pat yourself on the back. Good job. So questions about median. All right. So let's find the median test score. This one has 10. Let's list them again. It's the smallest. 62. 88. I almost forgot 88. Okay. Go ahead and find the median there. We all get 79.5. That is really close to what our mean was. Really close to it. That's nice. It's good when that happens. You'll find out why later, but it's good when that happens. All right. We doing okay? Questions, comments, queries, concerns before we move on to mode? I think mode's next. Okay. So this is important. You're so far doing good. Good. You will be, I think that there's even a question on the test. I think there's a question on the test about this. I know that there is in the lab. I can't remember if there is on the test. But this right here, something that you're going to want to tab and refer back to, especially since I have a hard time remembering this sometimes. You're going to want to put like a post-it note there or tab or something. So if our data set is skewed left, our mean is going to be significantly smaller than our median. So now 79.5 and 79 were really, really close. My mean was only 0.5 less than the median. That's not really skewed at all. Those were basically the same. Now, if that's significant difference, if my mean would have been like 70 and then my median was 79.5, I'd call that significantly smaller. If it's symmetric, the mean and the median will be really close to the same value. If it's skewed right, our mean is going to be significantly larger than the median. So this is it. The tests are open notes, yes. They're open notes, open calculator, not open book or open friend. Okay. I'm going to give you a second to write this stuff down if you're not one that prints off PowerPoints, because this is important. So just make sure that you keep this somewhere where you can easily find it. You're going to be mad at yourself if you can't find it later on. It means you can't ask a friend for help. Just, a friend open to giving you answers. All right, let's move on. All right. So I was super, super nice and I put these in order from smallest to largest. Isn't that nice of me? You can talk to your dog. Yes, I don't think your dog is going to help you. So these are prices of homes in Lincoln, Nebraska. So take a look. My lowest value is about 80,000 and the highest is about 350,000. Huge difference in lowest to highest. I'm guessing the 80,000 one is probably like a foreclosure or something. I'm going to show the median and the mean on the next page. I think I am. Am I not? I am. So the mean price is 168,320 and the median is 148,700. So based on what we saw earlier, my median is significantly smaller than the mean. I would not call these close. So if my mean is larger than my median, what is my skew? The mean is larger than the median. What is the skew?
Right.
Yes, good. So let's go back over here. Mean is substantially larger. We're skewed right. Good job. That would be the kind of questions you might get on my open math, is it'll give you something like this, and it'll ask you, based on your mean and median, what and how is your data skewed? What is the shape of your data? So this is a great way to tell the shape is by looking at the mean and the median. Good job. All right. So you can see right here, here's the graph of those data. You can see that there's a tail out here. Even though it still, I mean, I've been teaching this for a lot of years and it still annoys me that skewed right is because of the tail, not because where the bulk of the data is. They didn't ask me when they were naming it and they should have. I don't like it. All right. So once again, I'm not going to make you calculate this. especially since these are not in order. I would never make you do 50 of them. I'm not going to make you put 50 of them into your calculator. I will on Excel, but Excel's easy to highlight 50 data values. But I'm not going to make you do it by hand. I'm not going to make you do 50 in your calculator. But these are birth weights. So 50 sampled babies. And we're going to take a look at the shape of the distribution and talk about which measure of central tendency we need to use. All right. So I took this out of your book, this right here. I don't remember where, but I took it out of your book. So here's the picture from the book. So look at my mean and my median are both right here. They're like really close to each other. So because they are really close to each other, this is roughly symmetric. They are not exact. I think the median was like 7.4 and the mean was like 7.5. So they were really close. I don't remember exactly, but they were super close to each other. So because they're super close to each other, it is roughly symmetric. And we always say roughly. Statisticians don't deal in absolutes. It is roughly. And it looks like it might have a slight skew, but it is pretty much symmetric. All right. So the mode is almost completely useless. All the mode does is tell us which data value we see the most, which observation occurs more than once. The mode is pretty much only super useful when we're dealing with categorical data. So categorical data, there's no other way to determine center other than looking at mode. Which color M&M showed up the most? Which color car do we see the most on the street? Things like that. That's what the mode is for. Which observation do we see the most? Which dice, I guess that's discrete. Which dice did we roll the most frequently? So ending with Mike Pence because I didn't want to make an extra column just for one person. Ending with Mike Pence, this is the birth state of all of the vice presidents we've had so far. So we're going to take a look at the frequency distribution and determine the mode of this data set. So here's my frequency distribution. I tallied up all of the different birthplaces. And as you can see, New York right here has 8 vice presidents born in New York. So our mode is New York. It is the most occurring data value. So, because this is really the only kind of center that we can do with categorical data. This is my last slide. Can you believe it? It's only 6:13 and this is it. I told you guys it was a super short one.
So
All
one
right.
more question.
Yes.
Say we're doing like I was just talking about like dollars. If the entire value is not the same, including the change, it's not the same.
Exactly.
It seems simple. I just wanted to clarify.
No, that was a great question. So I have a lot of people that'll just say, oh, it's, $89 or whatever, because there's more than one that has the dollar amount part, but not the change. It has to be the whole thing.
That's the same with the decimals as well.
Yeah.
Okay.
So the entire thing. So if it's 89.45, then you have to have two that are 89.45. 89.47 would not be the same. Okay. So this tells us this table is good if we this a really great way to kind of explain the different averages and when to use them. We use the mean when we have quantitative data and roughly symmetric. We don't like to use the mean if we're skewed right or left. Generally, symmetric data is when we use the mean. Median, we use this when it is quantitative, but when we are skewed left or right. So if we have a skew either way, we will use median. It becomes more accurate and it's not skewed by outliers. We use the mode when we are using categorical, aka qualitative data, or if just for some reason you want to know like which dice roll did we have most frequently, or you know, which dollar amount showed up more frequently on my phone bill or whatever. then we would use the mode. We hardly ever use the mode except for categorical. But this right here kind of gives you a good rule of thumb of when we use each of them. I'm probably going to, I'm pretty sure that on the test, I will describe a set of data and ask you what you should use to describe the data and say like mean, median, or mode. I'll probably say something like, I have a data set with extreme outliers. Which measure of central tendency should I use, or which way should I measure the center? And you'll choose mean, median, or mode. If I have an extreme outlier, I'm going to use median. The answer is almost never mode. All right. That's actually all I have for the lesson today. I told you guys I was going to give you a short one. So this was only 45 minutes. Are there any questions for on recording before I turn off the recording? Any question for that everybody should hear?
Can you go over again why you use the median with skewed data? I was writing notes when you explained it earlier.
So let's say I have, okay, I'm going to go back to let's go back to the data that we have back here. Okay, where are we? Go back to this data right here. Okay. Whoa, my thing just flipped upside down. And I do a little bit of erasing, just a second. Okay. So right here is the data all lined up. I'm going to find the mean of this data real quick. This is going to be just it's going to show you why. Okay, divided by 8. Okay, so my mean here is 30.5. Okay, my median was, I'm looking for it. My median was 24.5. Okay. Now let's say that somebody came to the company and they have a super long drive. They have to drive. For some reason, they're commuting 3 hours to work every day. Okay. So now my median only shifts to 26. So my new median is 36. Or 26. Man, I can't even write down the right thing. My new median is 26. My mean is now, just a second here. Plus 180 divided by, I have 9. My median or my mean jumped all the way to 47.1. So when I get an extreme value, the funky E, oh, just a second, I'll talk about the funky E. Okay, so my mean by that one extra data value was pulled 17 higher, whereas my median only jumped 1.5. That one data value pulled my mean way up. So it kind of gives you a false idea about how far most people travel for work. So when we have skewed data, the median is more resistant to extreme values, whereas the mean doesn't resist those values. It's pulled one way or the other. Peer pressure affects the mean. Peer pressure does not affect the median. Does that help?
Yes, thank you.
Okay. Y'all want to know what the funky E is, huh? Where is the funky E? Is it back here?
It's on the last slide.
Oh, it's on the last slide? Okay. Y'all want the funky E, huh? Uh-oh. It's actually a capital sigma, I think, believe. This right here is just the summation. This is a summation symbol. It means add them all together. It means add all the data values together. So that's all it means is add them all up. Add up all the data values and then divide by how many there are. It's just a shortcut way of putting that. You're not required to remember what that means. But that's all it is it's just to add all the data values up.
Can you repeat what you said about the extreme outlier? You had said something, I think you said the extreme outlier is the mean.
No, the extreme outlier affects the mean.
Affects the mean.
So
Okay.
the mean can't resist outliers. The mean so if I get an extreme outlier, it's going to the mean in its direction.
Gotcha. Thank you.
Whereas a median can resist that outlier, but a mean cannot. Does that help? Those are great questions.
Yes.
Okay, good. Any other questions for the good of the group before I turn off the recording? Okay, I'm going to turn the recording off. If I can find the button. There it is.